Welcome and thank you for joining me for another episode of the Husqvarna Water Connections webinar series. I'm your host, Richard Restuccia, and today we're going to be talking about something that is going to make a major change in agricultural irrigation, and that is the push and the continuation of people moving to automated irrigation systems. It was a couple of years ago that we finally had more pressurized irrigation than we had flood irrigation. And that was kind of a milestone a couple of years ago. And now you can see a real push to automate irrigation systems for a multitude of reasons that we'll get into today. And really what we're going to do today that I think is so important is we're going to provide you with some very usable tips as you move through this automation, going from a manual or flood to a automated system. We give some very usable tips today to make this a painless process, and more importantly, save you some money on this too, and any potential mistakes you might make. My guest today is Perry Continente, and he's going to be taking us through this presentation. And anybody who's been involved in agricultural irrigation in California knows this name. He founded Precision Irrigation West. And let me tell you, if I was a grower or I was starting something in the Central Valley, Perry would be one of my first calls that I would make so that I could get some good advice on how to automate my system, or just any advice I needed on irrigation as well. Perry, welcome. Thank you for joining us today.
Well, thank you, Richard, and thanks for the kind words.
Yeah, you bet. You earned those. I've been around the industry long enough to have heard a lot of positive things about you.
Well, again, that's nice. Well, today we're going to talk about automating your system and why you should automate your system, or why you could automate your system. And everyone seems to want to have that information on their phone now, and it's very, very easily done. There are a few things that we'll discuss today that'll talk about why you might want to do that or how you could do that. So
yeah, and I think the other thing, Perry, too, that I've in conversation I've had with you is it's as much about why you want to do that as to how you can do this, and what types of irrigation devices, pumps, meters, things like that you should be purchasing.
Well, just about everything you can think of it can be overcome. Every challenge you can think of can be overcome. So we're just going to touch on the basics here today. Okay. So
yeah, that's great.
Get started, I suppose. Huh? Okay, first of all, this is an old picture of this is the way it used to be done pretty much everywhere. And first of all, is your system automatable? Can you automate a system? Well, this system obviously cannot be automated. Is your system worth automating? I mean, the first thing you want to do is make sure that your system is sound, has high uniformity, a proper application rate. And before you move towards automation, make sure that you're not spending money on something that needs to be fixed from the ground up.
Perry, if I was trying to determine if my system was worth automating, how would I do that?
You might first have it evaluated, so you can do an evaluation, see what the uniformity is of the system that you have, and what the application rate is, and how many inches per hour are you putting on, and is it enough to meet the demand at the most critical time? And if those two answers are yes, then you move forward, or maybe it's a new system. So there's lots of systems out there, whether they're new or if you're beginning just the planning of your system, plan for this. Or if you have an existing system, you need to look at some of the things and determine whether or not you need to make what changes you might need to make in order to make it a system that you want to automate.
Yeah, and who could do that evaluation for you, right? If I wanted to hire somebody outside my own company or my own family.
I would say Cal Poly San Luis Obispo in California, and there are probably a number of. I would go to my university system that they generally have in every state, and find out who can do the automation, or who can do the, excuse me, who can do the evaluation for you.
Yeah. Okay, great. Well, go Mustangs. Somebody
All
actually
right.
sent me a Cal
Yeah,
Poly rodeo hat today.
yeah,
So
I,
should have
because
worn it.
I'm a
If I
student there
known
at
you were going to do the
university.
plug, I would have worn it.
Yeah. All right. So first of all, we'll talk about some of the advantages of like why you want to automate. And one of the first things is execution. I mean, making sure the water comes on and off when it's supposed to. And I can tell you that I know that there was the largest farmer in California, Paramount Farms, had a way to figure out whether the water was on or off by looking at their pump records. And they found that it was all over the place when the water was supposed to be on versus when it was on, when it was supposed to be off, when it was just all over the place. And so they realized that they had a problem, because over irrigating and under irrigating is a waste of water.
You mean when I tell my irrigation manager or my irrigation guy to go turn on the water at 2 p.m. and turn it off the next day at 8 a.m., it doesn't always happen?
It does not. And it's conclusive. Now, and it depends on how big a farm you are. I mean, maybe you're doing it yourself, and you know yourself that that sometimes you're a little late or a little early, or maybe you want to go home. You know, there's lots of reasons for lack of execution. Let's put it that way.
Yeah, I think we've all had that experience of, whoops, did I turn that off or not?
Yeah. Or did I forget to turn it off? Or you got a flat tire? There's all kinds of reasons that you have that contribute to the lack of execution. And then, of course, if you need to pulse irrigate without automation, that becomes very difficult, time consuming and labor intensive. And by having good execution, you have healthier crops, and generally healthier crops are less susceptible to pests. And according to the UC Davis study, every time you put a tractor in a field, for whatever reason, spray, cultivation, or whatever else you might want to get that tractor in there, you're looking at close to a 1% loss in yield, according to their studies.
Yeah. So Perry, a couple things. One, I just want to remind all the viewers that we do have the Q&A open today. So if you have some questions for Perry, put them in the Q&A and I'll ask him when appropriate. And we already did have our first question, Perry, that I wanted to ask, and that is pulse irrigation. What is that, and why is it popular today?
Pulse irrigation is the idea of turning the water on for maybe an hour and then turning it off, and then turning it back on again, and doing this over and over and over. And many growers feel that they get a more spreading of the water across the crop bed by doing this, by implementing this approach.
Yeah, very interesting. So on for an hour, turning it off for an hour, 2 hour, 3 hour, whatever the cycle is, and then back on.
Yeah, and it's going to range depending on the grower's experience, the soil type, etc. And I believe what's happening in that, not to get too far into the weeds, but what's happening is that when you first turn on the water, you have a very high infiltration rate, and then if you turn on the water and get the soil wet and then turn it off, then your infiltration rate goes down, and then when you apply water again, it tends to go laterally rather than down, and that's sort of the idea behind this.
Oh, very interesting. Yeah.
Yeah.
So, right, a lot of people don't understand or realize, right, how far water moves laterally.
Yeah, and you know, you could do a whole thing on that as far as lateral movement of water and how unpredictable it is, but we'll move on, I suppose. Some of the other benefits that you might get are, of course, labor, and maybe it's the kind of labor of a person that you might want to that's in a pickup that goes out there to turn the water on and off. If that You're certainly going to still need to go out there and look at the system and make sure that it's working properly, usually every time that you turn it on. But with automation, at least it goes on at the proper time and goes off at the proper time, and it gives the person, if he's a little late there, to check to see if the sprinklers are all working properly, or whatever emission device you may have. It's not as critical, and also it's generally not as skilled labor.
Yeah, I just want to make a point here too, right? The simple fact of just turning water on and off, it doesn't sound like a big deal, but you know, at Husqvarna, we've got a product, a Beehive Ag product that turns center pivots on and off. And if you've got 25, 50, 100 center pivots, and you're going to get some significant rain that afternoon, sending somebody out in the truck to turn all of those off is really becomes a big management decision, because it's going to take so much time, energy, and money to do that. But the ability to just turn it on and off with your phone does make a huge difference. I mean, it's a huge money saver. It's a huge power saver from a PEMP standpoint, and it also a big time saver.
Yes, and chemicals as well, because you're not over applying or under applying. Now, when I think of waste of water, if you're not irrigating enough, that's a big waste of water, because if you don't apply the proper amount of water to hit the target, then your yields are going to go down. So your units of water per unit of crop will not be where it needs to be, or where it could be. So that's where the savings come in, or that's the way that we calculate the savings. We're not under irrigating or not over irrigating. Also, verification of a proper irrigation. That's also a big advantage of an automated system, is that everything is data-based. So that you have a record of how much water was applied, and you can use that for analysis. So the next part of it is a database for analysis and or reporting. Many places in California and other places you need to report how much water you've used from either a well or surface water, or for other reasons. But you can also check to see that the system performance over time is proper. So, for instance, if you irrigate, let's say 450 gallons a minute on day one, and down the road that's still right in there, then you know your system performance is good. And of course, the alarms that you'll get from high flows and low flows, low pressures and high pressures, are also very possible.
Yeah, all great points, Perry. That yeah, that is, I can't even stand one out as more important than the others. But I look at that high pressure, low pressure. Boy, that's a telling. That's a telling measurement.
Yeah, because everything is a snapshot in time. I mean, things change over time. So, like you know, your filtration gets challenged maybe more on sometimes of the year than others, and you need to react to it. So anyway, we'll talk about now we're going to talk about choosing the right automation system for you. So the first thing you want to do is figure out what you'd like to accomplish by your automation. There's all kinds of things can be automated. Cooling in Washington, apples, for instance, frost protection, irrigation. And do you want real-time information when you're irrigating? Do you want your automation system to you want to have that information on your phone, on an app? And it seems to be that's the big thing today that I would make sure that that you had. I mean, certainly you could buy a less expensive timer and plug it in, but then you would not have all of the benefits of what's available today. Okay. And of course, there's a combination of, or there's other things that I haven't thought about. I mean, it seems like everyone comes up with a different idea, and we'll say, yeah, we can do that. For the most part, most challenges can be overcome.
Yeah, and certainly you do see the technology happening today that really allows us to measure, right? Stuart Eyring did a webinar a few weeks ago, and he was in this webinar was talking about, we have the water, we have the technology to management. Now it's just a matter of putting it into play, right? Actually doing the management, and I think that's what you're, saying here very much too. We have these tools, we've got these great tools. They're not that expensive. We just need to use them.
Yeah. And so the next question you need to ask yourself is the water available, or does it need to be ordered? Or does it need to be, do you need to make some kind of open a gate or something like that in order to get the water to you? Or is it well water? Is it a pressurized system? Is it surface water? So in many places, you have to order the water a week ahead of time in order to get it there. So you need to make sure that you may have an automated system that only turns on when the water is available to you. And then, of course, that can be accomplished as well. Or is it in a reservoir, so you have water available, or a canal that's right next to you, so you have water available to you whenever you want to turn it on. And of course, that's the best situation. So some tips. Whatever you do, get it in writing. Make sure, because people forget what they, maybe what they were promised. But so I would say, make sure you get in writing. What will it do? What do you expect it to do? Do you expect it to start your pump for you, or is it already? Is your pump already on? Is it a pressurized system? What about valve control? How many valves can you open at one time? And that you make sure that you ask the person providing you with the automation system how many valves you can turn on at one time. And in the future, maybe you want to turn on more than what is possible with the given system. What's the support like? Do they have a 24-hour support system, or is it just one person who did it for you? And if you can't get a hold of him, then you're out of luck. And the last thing, the most important thing in my view, is that anything needs to be able to run manually. I need to be able to walk up to it and turn it on, whether it's a fertigation machine or a pump or whatever else you have, because the internet can go down. You can lose your phone. There's all kinds of things that may require you to walk up to it and just turn it on to get water out there.
Yeah. Perry, I just want to make a comment about the get it in writing. I work with people new to the industry, and sometimes they say to me, well, I feel like I sound like I don't trust the person I'm dealing with when I do this. And I say, no, you're not saying that at all. Right. These systems are complicated. There's a lot of things to consider. So remember, 30 days from now, 90 days from now, on either side, you may have forgot what you said or committed to. I mean, this is not unusual. And it's not that you're not trustworthy or they're not trustworthy. It's that we document this so we know what's happening or what should happen, what we agreed on.
You absolutely have to have a map of what you're going to do, and so there are no failed expectations.
Yeah.
You try to reduce the failed because that's the thing that the worst thing that can happen to you is to have an expectation that's not met. And it may be that from the other person's perspective, well, we never promised that. So if it's in writing, then everyone knows what we've sort of planted a flag in the ground, and we know what we're talking about.
Yeah. Yeah. You can always refer back to what did the agreement say? What did the plan say?
Yeah, because the road is really littered with people who have spent a lot of money on automation and that never really worked for them. And so I really think that you should guarantee it. That you should say it should do exactly what we say it's going to do, or we have to take it back or make it work.
Yeah, great points.
Anyway, the last thing before I move on, the last thing I'll say is it must be able to run it manually. Some of the system components and considerations are, do you have a centrifugal pump? Do you have a short coupled turbine pump? Do you have a deep well pump? How about water meter and water meters and valves and solenoids? Some like a butterfly valve is pretty much not automatable.
Mm.
You have to either change it to a butterfly valve that works electrically, okay, which requires batteries and maybe a solar panel, or you have to use a hydraulic valve. And typically in all automated systems, we're going to use hydraulic valves. Okay, here's just a picture of a typical installation, a short coupled turbine. That you can't tell it's a short coupled turbine by looking at it, but it is. And I want you to notice that down below there's a means to protect the pump is oil, and that needs to be automated. And right there. So make sure that your pump protection and pump lubrication and things of that nature are taken care of automatically. Otherwise, you can't automate the system, or you're automating the system without fully automating the system and causing issues.
Perry, we got a question coming in here now,
Yeah.
and this is it. How do I know, right, what pump to pick? Right, we know, right, one of the most least understood items in irrigation is pumps, and why I should pick one pump over another. And maybe you could touch on that, and maybe what not the manufacturing or brand, but what types of pumps you like to use.
Well, we like in automation, we like either a flooded suction, which means that the water level is higher than the inlet on on a centrifugal pump, or a short coupled turbine or a deep well turbine. And the reason for that is because it doesn't require priming.
Mm.
If you and we're going to talk, I'll show you a couple pictures of a down on my next couple of slides here of a centrifugal pump. And with the centrifugal pump, you have to make sure that it's primed, and that can be a problem for automation.
Yeah, priming sounds like I need to be there to do something.
Exactly, you do. And so if you're planning to automate a system and you want to leave that door open for you, I would use a short coupled turbine. Now they are a little bit more expensive, and that kind of goes with the territory. Or make sure that the water levels that you're working with are higher than the intake of the pump, because then it won't require priming. And here's what I'm talking about. This is a picture of a centrifugal pump, and you can see that the water level is lower than the pump. So the pump has to have what's referred to as a net positive suction head requirement, or the suction at the point where the, can you see my cursor there?
Yeah,
At that point right there, you need to have a suction that will bring that water up. In order to do that, this has to be full of water. And the only way to becomes full of water is with a priming pump. Okay. So if you're going to use this, now you can still certainly turn off the water, or you can send someone out there to prime it beforehand, but it can be an obstacle to automation. And the other thing that you need to be concerned of with these, they'll typically have some kind of pump protection, which is a pressure switch. And that pressure switch, in many cases, needs to be bypassed physically by hand when you turn the pump on. And if that's the case, you can disable that. And then if the automation system that you're using will protect the pump from running dry by a water meter hooked up to it, so that the controller has information that says if there's no water here, turn off the pump. And that's also very important.
Yeah. So Perry, I'm a grower. I don't want to have to worry about priming any pumps. I'm going to need some other type of pump than a centrifugal pump or
Then
that
what I would
setup.
do is
Yeah. What am I
now
going
see how
what am I going to
there's
have
a
to spend extra to do that?
well, I don't know how to maybe you can convince your pump manufacturer to or pump installer to do it for the same price. But typically, this is a short coupled turbine and it doesn't need priming. And this system happens to be automated. This is a system that I did quite a while ago, and it's fully automated. So the oiler's automated, the whole system's automated. And because of and it's one of the reasons we chose that kind of pump. So we're back now to issues of priming, whether or not the flood, if it's the flood suction, if the water levels are higher than the intake of the pump, then then you don't need a short coupled turbine. But you certainly need to be concerned with the pressure switch. And you need to make sure that you have pump protection within the automated system that you're purchasing. So now we'll talk about water meters. So how do we know how much water is going through the system, and does it tie in? Now, this is showing a really inexpensive water meter, but the output on these has never been very good. So I would recommend a higher quality meter and make sure that the outputs that it provides are accepted by the automated equipment that you're purchasing. For instance, does it require what's referred to as a dry pulse, an open collector, or 4 to 20 milliamp? Is the length of the pulse, how long it makes contact, programmable? And will your clock read it? Will will the automated equipment that you're purchasing read that pulse? And so you need to make sure that you have compatibility.
Yeah. So we've got another question coming in, Perry, and
Okay,
that's
sure.
and it has to do exactly what you were saying. How accurate can these water meters be? Can I rely on the information, and what do I have to pay? How much am I going to have to pay? I realize you're not selling water meters, so if you could
Yeah.
just put it in general terms, what we might have to pay.
In general terms, you're looking at the meter on the top, which is around anywhere from, depending on the size. Let's just say it's a 6-inch meter, maybe $1,200 to $1,500 for that meter, and it requires, and you can see it's got an impeller in it. So if a tennis shoe gets in there or something like that, it can cause it not to read accurately. And it tends not to be a very accurate device in the first place. The meter below is highly accurate, doesn't have any obstructions, and the price will be probably twice as much.
Yeah.
So you get what you pay for, and also the upstream and downstream straight pipe requirements for the meter on the top, or the saddle meter, would be approximately 10 diameters. So if it were a 6-inch pipe, it'd be 60 inches of straight pipe beforehand and 12 inches of pipe before you have any kind of obstruction, changes, valves, etc. Where the meter below, it can basically be against a valve. It has no upstream and no downstream straight pipe requirement, and it is highly accurate.
Yeah, that's interesting. So for not that much more money, you can do this right and be really happy.
Yeah, if you can't afford a water meter, you can't afford an automation system.
Okay.
All right. Just valves on and off. First of all, how many valves do you want be required to be open at one time? Make sure that you specify that, because that'll be a major driver of the kind of system that you purchase. There are systems that you can have as many valves open as you want at any time. There are systems that typically you can only have 4 to 5 valves open at one time. And for many systems, that's not a problem, because we're going to open maybe 2 or 3 valves and close those valves, and then open another 2 or 3 and move on. Other systems that maybe we're talking about for frost control or whatever, for whatever reason, you may have more than 5 valves that you need open, and then you may want to use a system that allows that.
Yeah. So I was going to ask if, what's a situation that you would want to open all your valves at the same time?
Let's say frost control, or maybe you're not so much worried about the uniformity of the system as you are just protecting it from frost. And so you may have enough water to do that. And it may require that you open more than 5 valves at a time.
Yeah, great point. Great example.
Yeah. And of course, there's a different wireless control. There's very good wireless control out there now. Is it line of sight? Which means that if you have hills or trees in the way, it may cause you an issue, or you may have to take measures in order to get around that. There are 2-wire systems that have, like, say, just 2 wires that go out to all the different valves, but then each valve has a decoder on it. And so that's how you open those valves. And with those, generally it's 4 to 5 valves that you can open at one time with an AC system. We also have DC latching systems, and those DC latching systems are generally not a limitation on how many valves you can open at one time. It's just the hydraulics. Will the hydraulics support that? That's the issue. So these are the kind of questions that you want to make sure that you understand when you look towards an automation system.
Yeah, these are excellent questions. Yeah, that you want to cover. That's for sure.
And finally, the U.S. in the U.S. we tend to be really focused on time-based. And so the 2 things you need to know if it's time-based is what's the uniformity of your system and what's the application rate in inches per hour. I believe a better way to irrigate is volumetrically. And that's either to know how many gallons you want to put on the zone or how many inches you want to put on the zone. And then your controller should be able to be set in that and to deliver volumetrically. And there you need to know, of course, the distribution uniformity or the uniformity of your system and the area of the zone size. And then you can establish a target for how many inches you need to put on or how many gallons you need to put on, and then set your controller to that.
Yeah, the volumetric base. Do you see that much in North America?
No, we don't. In the US, we're very time-based focused. In Israel, they're completely opposite. It's how much water do we want to put on in a zone.
Yeah, that's interesting. It'll be interesting to see if there's a shift here or not.
Yeah. Now, either way, I think is fine, but I just wanted to point out that you can do either way. Okay.
Great.
And that's all I have for you today.
Wow. You say all you have. That's a lot. It was a lot of good information. And certainly I do appreciate the tips, Perry, that all our viewers are facing automation and trying to make the move that direction. You just saved them tons of time and money. We have one last question, though, coming in that I want to be sure we ask you, and that is, anybody who's been waiting to automate, wait for better technology or something better to happen, do you have any advice for those that are waiting?
Well, I don't know, because I think that things are always improving, but the systems today are very robust and easily used. The ease of use is much, much better than it used to be. I mean, there were automating systems in the 70s, So will there be better systems tomorrow? I hope so, but what will that be? I don't know.
Yeah. That's a great answer though to the question of automation. You got to move now, right?
Yeah. Well, I'll tell you that my dad, when we were kids, he's going to get a color TV when they improve the technology, you know? So would you buy anything but a color TV today?
Yeah, no. Right, and we'll have better TVs in a year or two from now. I know
Yeah,
that.
I'm sure that we will.
We'll be swapping them out. So anyway, Perry, thank you very much to our viewers. I want to thank all of you and remind you that you can go to hydrarain.com, look at the webinars area and see all our past webinars for free. Or you can also listen to wherever you listen to your favorite podcast. We extract the audio out of this and put it on the podcast. Perry, one of the things that gets me very energized every week is this idea that people are out there working and listening and learning at the same time. That's very cool and energizing to me. So again, thank you for providing this content, and thanks everybody for watching. We'll be out for the next few weeks for the holiday, but we'll be back in January with some really good technological irrigation information for all of you. Thanks very much. Thanks again, Perry.
All right. Thank you.
Okay.